Okay, hello everyone. In this lesson I'm going to show you how to use the quadratic formula to solve quadratics. And as we know, a quadratic is an equation. One of the general forms we use is this. It's got a squared term if it's not factorized, and a can't equal 0 because if a did equal 0, it wouldn't be a quadratic anymore. Okay, and so the famous quadratic formula, which we could solve for it by completing the square. If we want to say get x by itself, well, getting x by itself is quite tricky. Okay, and we have the quadratic formula to use to solve for x. And what it is it's opposite of b, or you can call it negative b, but it makes it easier if we say opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay, and that is the world famous quadratic formula right there. We don't always have to memorize it because it's given on some of the formula sheets for the exams. So there we have it. So suppose we have a quadratic, and I say solve for x, and I give it as 2x squared minus 3x minus 4 equals 0. Okay, and I say, all right, solve for x. Well, this doesn't factorize, so we can't even factorize that if we wanted to. And so we've got to use a quadratic formula, or we could solve it other ways, completing the square. There's actually another way, which I just found out about last year, but I won't get into that right now. So the first thing we want to do is we look at this and we define what a, b, and c is, and we substitute it into this beautiful looking formula right here. So we've got a is 2. B is going to be the coefficient of this term, negative 3, and C is going to be my constant term, which is negative 4. Now the signs are important because that's what's important when we plug it into our formula. Okay, we don't want to call that 4, we don't want to call that 3, we want to call that negative 3 and that negative 4, and that's positive 2. So when we plug and chug it in there, we're going to say, okay, x equals opposite of b, and that's why I don't like calling that negative b. The opposite of b is 3 plus or minus the square root of, and here you got to be careful. I use brackets when I'm doing here. I say, okay, b squared is negative 3 squared minus 4 times a, which is 2, times c, which is negative 4. Let's make that a little bit bigger. All over 2 times a, which is 2. Okay, so that's the first part of the quadratic formula there. It's pretty beefy. It looks pretty good. Okay, now this part, just, FYI, this part under the radical symbol is called the discriminant, and that's going to say a lot about what the solutions are in the quadratic. If under here is positive, it's all good, and it's going to be a real number. If everything under here is negative, it's not going to be a real number. Okay, it's going to be an imaginary number or a complex number, different beast. So let's see what we get here. X equals, I'm not going to do anything with that 3 yet, plus or minus, square root of 3 squared is, well, negative 3 squared is 9. Now right here, just be really careful. I would just multiply all these together. Minus 4 times 2 times negative 4. Okay, because people get messed up. They go, oh, minus, and they multiply all this first. You can do that. Okay, I mean, if you multiplied all of this, you would get a negative number. And then you'd have to subtract that negative number, so you'd get minus a negative. So I just multiply everything and go negative 4 times 2 times negative 4, which I think gives me 32, plus 32 all over, and 2 times 2 here is 4. All right, now I simplify under the radical, and I get 3 plus or minus the square root of 41 over 4. Now right there, that is my exact answer. Okay, I mean, I can box that and go, these are my two solutions. Okay, one solution is x equals 3 plus the square root of 41 over 4, and another solution is x equals 3 minus the square root of 41 over 4. Okay, so these are my two different solutions here, and if you want to, I can get decimal, if you want to round this, which I guess a lot of times on a test we do want to round those and get decimal answers. Here I get, I think, if I did this right, I get 2.35 to 2 decimal places, and here I get about negative 0 point something, 851. Okay, and so I can say, all right, these are my solutions. These are my 2 solutions, and that's how I do it. Okay, and I thought to give one more example, I thought about rolling some dice. Okay, and just having these be A, B, and C, and seeing if I get a solution or not. Okay, a real solution. So let's try that. Let's say we'll say A is orange. No, wait, what did I say? I got to write this down. A is orange, B is green, and C is yellow. Okay, and I'll say if it falls off the paper, then it's negative. Okay, if it falls off the paper, it's negative. So let's see what I get here. Okay, so the green fell off the paper, so that's a negative 2. So the green is negative 2, B is negative 2, A is 3, and C is 4. Okay, so let's just see what I get here. So I'm going to say my quadratic is 3x squared minus 2x. This is close to the last one I got. Wow, that was interesting. Pretty close. Plus 4 equals 0. Okay, so let's just see what I get here. And I've got A equals 3, B equals negative 2, and C equals 4. If you don't want to stay through this part of the video, you don't have to, but I just randomly rolled, and let's see if I get a real solution or not. X equals negative B, the opposite of B, which is 2, plus or minus the square root of B squared, negative 2 squared, minus 4 times A, which is 3, times C, which is 4, all over 2 times 3. Okay, and we're plugging along, we're doing this, and let's see what we get here. I think I'm going to get, I just randomly rolled that, I think I'm going to get a non-real solution, I think. Let's just see. So negative 2 squared is 4. Now here, there's no other negative numbers here. I get minus 4 times 3 is 12. 12 times 4 is 48. I get 4 minus 48. I hope I did that right. Let me just check. 4 times 3 is 12. And 12 times 4 is 48. Okay. Now here we're going to say, hang on. Something's going to happen because when I plus or minus 4 minus 48, what does that give me? It gives me a negative 44. And as you know, math teachers will say, we can't have the square root of a negative. Well, you can. You can have the square root of a negative. It's just not going to fall on a regular number line. Okay? And so right here, you can have a number of things. The square root of a negative is going to be a non-real number. So there's one, you could say no real solutions. There are solutions. I'm just not going to get into them in this video. You'd have complex number solutions, and you could say imaginary solutions only. And when we say imaginary, we mean imaginary numbers. Okay, yeah. So that's quadratic formula, just some of it, and that's how we use this in order to solve quadratics. So this guy had 2 real solutions, and this one here had none, had no real solutions. Okay, so yeah, that's it, and I hope you get some kind of understanding of quadratics from this video. Thanks for watching. See ya.